Hello viewers, welcome to this session. This session is initiated by your own teacher community. This community will help you in guiding your project and also in clearing your doubts. So let's move ahead with our session. This session is about Lte Spice. What is this Lte Spice, why we are using it, and how we're going to use it. This will be cleared in this session. So basically, Lte Spice is a simulation software which is used to simulate the circuits. I mean, it can be analog circuit, digital circuit, or mixed signal circuits. What we do is we can create the schematic of the circuits and also analyze the waveforms. Now, the advantage of using this software is basically we can avoid the losses which can be occurred in hardware. Now, suppose you take two components or three components, let's say resistor, capacitor, and took a breadboard and connect on it, and you gave a supply. And suppose you made a wrong connection. So all the components will be burnt out and there will be losses of component as well as. So to avoid that, basically we will do this software, this simulation software. So where you can do as many mistakes as possible. So let's go ahead, and this software can be downloaded from Analog Device website. It's free of cost. You don't have to pay anything for this software. Okay, so let's go ahead with this session. Okay, so this is the Lte Spice software, and from here, you can choose new schematic, or you can open the pre-existing schematic. So we are going to make a new schematic. Okay. So now you can see on the top of the screen there are too many icons. So I will talk about each. So this is the Spice directive. From here you can write commands and all, which will be clear. I will be clear these in a few minutes. And this is the text. You can write text, for example, what the circuit is, and different type of text you can write. Now from here you can choose the components. As you can see, this is the diode, Zener diode. This is the resistor, you have seen it. And some basic things like this is the Nmos transistor and diodes. This G is basically voltage dependent current source. So the output is current and the input is voltage. So their ratio is conductance, which is equal to G. So let's make a simpler circuit, and we know the simpler circuit is simpler resistive divider. So let's make a resistor divider. So we go ahead and select the component. Let's say resistor. Now this is the resistor. Using Control and R, you can rotate it like this. So we place one resistor here and another resistor here, and then press escape. Now this is for wire. You can connect this with a wire. Again, press escape. Now this symbol is called drag. When you click it and then again click on the you want to drag, you can drag this. Now the connection will be secure. The connection will not be broken. And if you move to this is called move. If you click on move, now this will move. The connection will be broken. So this is the difference between move and okay. So now we have placed the resistor, and you know that without a source, nothing will work. So we need a voltage source. So we again click on component. These also are arranged by alphabetical order. So you can see this is the voltage. Yeah. So now we connect this voltage source. Again, press escape. Now we click drag and then this again. Now put here, then again click on wire and yeah. Now the circuit is not complete. We need a reference voltage. As you know that you have studied in your theoretical classes and you must know that they have shown reference voltage. Without it, the circuit won't work. For example, let's say, suppose we run a simulation command. What is this OP? Then I will define. So it is not running. Okay, because the values are also not defined and also the ground voltage is not there. So this V1 is the name of the voltage source and V is the voltage value of this voltage source. So we will give, let's say, 5 volts. And the value of this R will be 1. And again, the value of R. And now let's put a ground. This is the symbol for ground. This, and I took this, I took ground from this symbol. Now let's drag this a little bit. Yeah. So now let's move to simulation. From here, you can click on run or also edit simulation command. This will open the same. Yeah. So now there are various options you can see. So this is the transient, and the transient is always with respect to time. So it won't be applicable here because all the things, all the values and resistance, all the things are constant. AC analysis, there is no small signal here, so we won't need this. DC sweep, yes, we can do this. DC sweep is means we can sweep the voltage source. And this is for the noise. This is for the transfer function. And this is for the DC analysis. First, we will do this. Okay, so now this is the command .op. Now we will do, this is the symbol to directly run the simulation. Yeah. Now you can see that VN001, VN002, these are very confusing. I mean, which is N001, which is N002. So to avoid this, we can use label net. It is used to name the net. For example, I write and VA. Now again I yeah. So now you can see that VIN is 5. So this node is at 5 volts. And this V out is at 2.5 because this will be resistor divider. So this V out will be half of VIN. Now the current will be 2.5 ampere. Now you may argue that why the current in V1 is negative. The reason is that because it is going from negative to positive voltage, from lower voltage to higher voltage. That's why the value is negative. In resistor, it is going from positive, higher voltage, lower voltage. That's why it is positive. Okay, so now it is clear. Now we will go one step ahead and now we will do sweeping command. Now this is the DC sweep in which we sweep. Sweep means we change the DC voltage. So let's say it is asking name of the source. So name of the source is DC. Now type of sweep is linear, octave, decade, or simply by list. List means you can give particular numbers. So we will go ahead with linear. Let's say start value is 2 volt, stop value is 10, increment is 0.5 volt. So we will do like this. Now you can see that here this is semicolon and this dot. Semicolon means this command is deactive and this dot command is now will simulate. So if we do, yeah. So now a graph window is open and this is the schematic. Now you can see that this is x-axis. This is the input voltage which is going from 2 to 10 volts. So now let's suppose we plot V out, and to plot a voltage, simply put the cursor to line and this red pen will appear and just click on that. Now this graph is up. Or if you can change the color, you can also do that. To click on this V out, cursor will appear. You can also move ahead to see the values. We see in the bottom right, you can see the cursor 1 and the respective x value and the y values. And suppose you want to measure the current in R2, let's suppose. So what you want to, you just go ahead to R2 and just click on this. This is IR2. And you can also differentiate between these two graphs by plotting plot plane and move this IR2 to here. So you can see these two graphs have been. Okay, so now this is the DCC. Now we will go further. You can close this. Oh, sorry, I'm closing the schematic. Okay. So now we will make a new circuit. Let's say RC circuit. So again, we will go resistance, then cap, then again go to source. Okay, then take a wire, connect all this. Now give this voltage, let's say 6 volt. This is 1K means 1000 ohms. And this is 1 micro. You don't have to specify farad or units. Basically, it will take care. You can see capacitance in farad. So you just have to mention the value. Okay. Now connect this. Now let's say simulate DC. Now you can see this circuit does not have a conduction path to the ground. So which means that there is no ground. So we have to connect a ground. So just this ground. Now this. Now 6 is. Oops, it's here. Okay, now simulate. N002 and N001. These means node 001, node 002. You can also check from here. Let's say if we hover the cursor on wire, you can see in the bottom left, this is node N001. And this is node N002. So it's like a information. So please always care of the whatever appears on the left bottom side. It will be useful to you. So now let's give next. Simulated. Okay, so now you can see that V out is 6 volt. Why this is 6 volt? Because in DC, capacitor will act as a open circuit. So this V out is directly shorted to VIN. There is no path for current. So that's why V out is 6. V in is 6. And you can see the current is pretty close to 0. I mean 6 into 10 to the power minus 18 is approximately 0. You can say that is 0. So the current. So now let's do some more analysis which will applicable to capacitor. So AC analysis comes. Let's say AC analysis. So in this, you can see this is saying type of C, octave, decade, linear, or particular you want to mention. So let's say we go to decade. Now number of points per decade, let's say 10. Now start frequency, let's say 10 Hz. Stop frequency, let's say 10 Hz. Now if we simulate this, this is saying no AC stimulus found. Why? Because there is no AC voltage source. So we have to mention AC voltage source. So here you go advanced. And from here you can see we have given DC value, but no AC amplitude was given. That's why it was throwing error. So if an error comes, please don't panic. Just see the error, what the error is, and try to negotiate. Let's say we say AC amplitude is 1. And again, simulating. See, the error goes away. Now let's say we want to look at V out. See, this is in dB, the amplitude of V out, and this is phase. So if you can see, you can also change to this linear, logarithmic, or decibel. How are you gonna do that? Just go to axis, then right click on that, and let's say I'm going to linear. And so you can see that it is acting like a low pass filter, and this is the phase. And the another thing you can do is that try to find the transfer function. This you can also find the transfer function, but this is the DC small signal transfer function. So let's say V out voltage at node V out and source is V1. Let's say it's C. Transfer function is 1. Why? Because the capacitor is acting as a open circuit. So V out by VIN is 1. And input impedance is simply 1K, which is, sorry, input impedance is from this side. So if you try to find out, the input impedance will be this pretty large. And the output impedance is simply remove the capacitor and look from this V out terminal by shorting the input. The output impedance will be 1000 ohms, which is correct. So now do some more circuits. Let's say if you want to delete it, the command just go to this, cut this, this. It will just remove the, or you can just drag this and clear off. Now we will look at the some more advanced circuit, let's say with transistor, let's say Nmos. So this is Nmos. Now you will need load. And if you want to zoom in or zoom out, just use this scroll up and down. And suppose if you lost somewhere and you couldn't find the circuit, just go to this room full content, the circuit will reappear. So now let's quickly make the connections. Now we will need a voltage source. So again, we go to voltage and a voltage source, then connect voltage to the circuit, then give the reference path. Now give the values. For example, you can also pick different MOSFETs, and if you right click on the resistor, you can also select different resistor depending on the tolerances or power requirement you have. Let's say resistance is 1, this is 1, this is 1, DC value is 10. Series resistance is the internal resistance of the voltage source. I mean, if you want, you can give it, but ideally it always will be 0. So let's say I gave 12. So it means it has some series resistance. So you can remove it. So now if you simulate this DC operating point, and let's say you label the net, for example, VG, VG for gate, VD for drain. So let's say we simulate this. VD is 9.99. ID in this transistor is pretty low. It is around 250 microamperes. So it is quite low. So just an example, and this I in these tranches basically the current will be 5 ampere because you can see the current in the gate will be 0. So 10 divided by 2 is 5. So this in this session, basically we learn how to make a basic circuits and how to run basic commands such as how to find operating points, how to do DC sweep, how to do AC analysis. That's all. Okay, thanks.